All right. So sorry, Zoom is not behaving particularly nice today. And so I was requested that I would go through the equation inequality challenge problems and kind of go through those solutions. So here we go. In question number one, there's a variety of ways that you could do it. You could cross cancel a few pieces, but I have historically found it to be far easier just to go ahead and simplify the numerator and denominator independently. And I notice that 5 times 6 is 30. There's 4 x's here and 1 there for 5, and y to the 7th. And in a similar way, we've got 20 in the bottom, and there's 3 x's here and 3 there for x to the 6th, and y to the 13th. Seems like a lot of information, but it simplifies down pretty nicely to 3 over 2, since those are both divisible by 10. And if I have 5 x's on the top with 6 on the bottom, that would leave 1 additional x on the bottom. I could call it x to the minus 1 on top, but x in the bottom is usually preferable. And similarly, y to the 6 would be the final answer. So fairly simple, quick problem. Okay, number 2 is a little bit harder for people. First thing that I would choose to do is I would choose to notice that each of those things with the negative exponent, which would be this piece right here and this one right here, I'm going to go ahead and move each of those pieces. So I am going to leave the 7 and the 4 where they are. I'm going to ignore this minus 4 sitting on the outside. And I'm going to just decide to take these 3 x's right here that have a negative exponent and join them up with the 5 x's that are in the bottom. Let me see if I can zoom this in a little bit tighter. Okay, see if that shows up just a little bit better. And now I have a total of x to the 8th in the denominator, and similarly these 2 y's down here should have been up on top and join the 4 that were there as y to the 6th. Now at this point in time, things go fairly quick because powers of powers is a product, and 6 times negative 4 is negative 24, but we want to remember that anytime you have a negative exponent, that by definition is a reciprocal, so that should be y to the 24th in the bottom. In that same way, 8 times 4 is 32, so that's going to bring the x to the 32 into the numerator. Now the part that's a little bit less friendly for people is we still have this 7 that needs to be raised to the 4th power. But 7 times 7 times 7 times 7 is a pretty large number, and because it's a negative number, it needs to get flipped over, and that's where this 2,401 comes in. And similarly, 4 times 4 times 4 times 4 is 256, and yet again, I had to take a reciprocal because of the fact that it had that negative exponent. Now, what sets number 3 a little bit apart from the previous one is these each have their own independent little parentheses. So first off, if I took negative 2 to the 9th, I hope everybody understands that negative 2 to an odd power is in fact going to be a negative answer. And 2 to the 9th power is 512. And you'll notice that I chose to write it on the bottom because 2 to the 9th is 512, but it needs to be flipped over because of the negative exponent. Now, I'm going to go quickly through the rest of this because powers of powers multiply. I'm going to write the a to the 36 on top. But when I get to a b to the minus 18, I'm going to choose to write that b to the 18th as a denominator. I now have a to the 36 down here again, because 6 times 6, and the b to the 24th, right now look, it would be negative 24, so I'm going to choose to take it from the bottom and put it on top. Now, just like the problem up here, I need to do just a little bit of simplification to get down to this next level. So that negative is still there, the 512 is still there, but you'll notice that these a to the 36 seem to completely go away. And then all that I have left is 24 minus 18, which is b to the 6. And that kind of satisfies all of these little exponent-based questions. Now down here in question 4, what we're going to do is we're going to go ahead and consider what that fraction buster would be. And between a 3 and a 4 and a 12, the lowest common denominator between those is going to be 12. So I'm going to multiply each of these pieces one at a time by 12. So 12 goes in, 3 goes into 12 4 times, 4 goes into 12 3 times, and 2 goes into 12 6 times. So notice I'm trying to simplify, so I multiplied each by 12 and reduced. Then the distributive property is going to create a 20t minus 4, a 3t plus 15, and last but not least, a 6. So I've got 23 t's. It looks like I have plus 11 is 6. Not a problem that most people have struggled too much with, but a quick division yields an answer of negative 5 over 23. Now, as well as people do on this problem, the same thing happens on number 5, but this negative right here seems to cause people pain. So the lowest common denominator that I can find between all of these would be 30. So when I hit it with a 30, hit it with a 30, and hit it with a 30, so I'm going to have 6n plus 12, and here comes the dangerous part. There's a negative 10 times 3n, and a negative 10 times negative 1, and I'm down to 5n plus 10. Now, a little combination of like terms can bring these two pieces together. Looks like I got 22. I hope I don't make a mistake here because it's certainly easy to do so. I'm going to go ahead and, just because this is what I saw a lot of you do, I'm going to move all the n's to the left side, and I'm going to move the 22 to the other side. And notice that now when I divide both sides by negative 29, you want to remember when you divide both sides by a negative, that chooses to flip that inequality. And so it looks like n is less than or equal to 12 ninths, okay? Now off to number 6. Thank you, John. So up here, purposely I kind of put this 2 in this place because I knew that would kind of disturb some of you. Some people choose early to subtract 2 from all 3 sides, and that's not a bad idea to do. So I'm going to go ahead and do that. I'm going to go negative 7, 3 minus 7x over 9, and if I subtract 2, 1/3 minus 2 is actually negative 5/3. Now if you chose to go the other way, it's okay. And then I just would multiply everybody by 9. That would allow these little fractions to go away. Multiplying by 9, right here, 9 would cancel to leave a 3. And now a little bit of movement of that 3 right there. That'd be 66. And we subtract 3, we're at negative 18. And this is the big bad step that a lot of people forget, is that when you choose to divide by a negative, remember that actually makes that inequality flip over. So I'm going to have 66/7 x and 18/7. That feels a little bit awkward to write it that way because we usually write it from left to right, and this one is actually written from right to left. So we could have written it in interval notation as 18/7, comma, 66/7, close, okay? Now 7, actually a lot of people go way too far with this one, but the first thing that I'm going to do is I'm going to isolate this piece right here. So I've got 2 of these are equal to 9, or in other words, 3x minus 4 squared is 9/2. Now that I have that square, that perfect square that's sitting right there isolated, I could choose to take the square root of both sides. Now, there's a nuance step that I'm going to show in this next piece, because when you take the square root of 9, that's not a big deal. But the square root of 9 is 3, but the square root of 2 is just root 2. And so a little bit of work, move the 4 across. And my last step would be to divide each of those pieces by 3. And notice 4 divided by 3 is no big deal. But 3 divided by 3 is going to cancel that. And this is an okay answer, although it's usually frowned on to have a root in the bottom. So the fix that you're supposed to do is multiply the top and bottom by root 2. That's called rationalizing the denominator, which is, I know, a topic you studied back in Algebra 2. And we have plus or minus root 2 over 2. Now, there are a variety of the answers that I would have accepted on that particular question, but that is probably the cleanest looking answer. Okay, home stretch. Completing the square. We talked about how when you complete the square, we don't like to have any leading coefficients. So the first thing I'm going to do is divide everything by 2. And in fact, one more thing, I prefer not to have anything in this little hole right here, because what I'd like to be able to do is actually do the whole cut in half and square. So keep in mind when I cut 11 in half, 11 halves in half, I would get 11 quarters. I'm just writing that there. It almost looks like a smiley face, just saying, hey, that's what I'm going to have. But when we square that, I get 121 sixteenths. Boy, that's a terrible looking answer. So what we have is x plus 11 quarters. You know, we've talked about that. Whatever that value was when you cut in half always goes here. And then if I combine these two, this is really 8 sixteenths, which is 129. And a really nice thing happens that I promised you is when you take the square root of both sides, almost every time something really nice happens. Because although root 129 is not so pretty, the square root of 16 is 4. And so all we have left to do is slide that 11/4 across. And beautifully, we already have this common denominator, so we're going to be able to slide that across and be okay. Now, question 9, we're almost done. I'm going to isolate this absolute value. I'm going to bring the 18 across and divide by 2. That's, I think, a fairly clear step. Then we're just going to go ahead and split this up into our two little possible things. One is it might have been 9. And if it was 9, that's going to lead me to an answer of x equals a half. But it's possible that 4x plus 7 could have been negative 9, which leads me down a little path that leads me to negative 4. So the two answers that we get for this one are 1/2 and negative 4. And if you tried it, plug in a half. What's 4 times a half is 2. 2 plus 7 is 9. The absolute value of 9 is 9, and 2 times 9 minus 18 is, in fact, 0. You can check that answer without too much difficulty. And in a similar fashion, number 10, this is the last one I'm going to choose to go over. But as soon as you bring the 9 over and divide, you're asking, where is this absolute value equal to a negative number? Well, you want to remember that an absolute value looks like this. It looks like a V sitting up here in the positive, and it's asking, when is it going to be equal to this negative 3 down here, which is not possible. That is no solution. Now, for the sake of this particular video, that's as far as I would like to go, because I would like to go over the bonus, but it's a little bit of a harder problem, and I might share that on a separate video. So hopefully this is helpful. Look at the ones that you need to. All right, good luck, and bye.